introducing the bus network, because when I leave this slide out, I always get a lot of questions, people asking afterwards. We have 9,500 buses operating in London, but different than a lot of major world cities. You can see the graph there in the red and blue. The red is the operator kilometres of the buses that drive in London. The blue is the passenger kilometres. We've had a lot of growth in the bus network in London from the 1990s. So obviously, if we just left things as they were, we'd have a lot of increase in emissions. And I'm not a transport planner or a policy kind of guy, but if you look at the red line is always, the red line to blue line ratio is always interesting to me, because we've had to increase the kilometres the buses drive first. And then after that, in the blue line, you can see all of a sudden a huge ramp up in passengers start to use it. So the frequency of service is really important. No one wants to wait for a bus in London for more than 5 minutes. If you go to a bus, people will get an Uber or something instead. People will not wait. So we've got quite a frequent network. So keeping the environmental impact of the bus network down is a huge priority, whilst providing that really important public transport service. This is just to say that we have the same challenges everyone in Europe has, and more so actually. NO2 is the worst in London and in Europe. We just about meet PM. Every now and again that goes a little bit up and above, and we still have measures to reduce PM. And we're doing I'm not really going to talk about the CO2 reduction measures, but we've got a lot of measures to reduce CO2 with hybrid buses and electric buses, etc., in the future. So I mentioned earlier on about London. So there's the central London dotted line you can see there. That's going to be the ultra low emission zone in 2019, April 2019. All vehicles in there, if they're diesel, have to be Euro 6, light and heavy duty. Light duties can be Euro 4. Petrol cars can be Euro 4. The whole map of London you see there in 2020, get the date right, in late 2020, that's going to be, the whole of London will be Euro 6 for heavy goods vehicles. They all have to be Euro 6, whether they're gas or diesel, have to be Euro 6. And then the central dotted bit that's when the ULEZ in the centre of London is expanded, and all the cars in that zone will have to be Euro 6 of the diesel and Euro 4 of the petrol. And it's nice overlaying that on the model NO2 concentration. You can really see why we've focused on the ULEZ bit first in 2019, and then moving it out into the north and south circular. And over to the west there is Heathrow Airport, and they're doing their own measures for NOx reductions separate to us, basically. And this is just a quick map showing where the NOx in London is created. And this is the, if I go back to the slide, so if you take the whole area of London, you break down where the sources of NOx come from, you get that kind of picture there. If you break that down to a specific street, you get a very different picture. There's some streets where there's just buses, and so buses are the biggest contributor there. But that's the overall view of where the sources of emissions are in London. And then on to our famous MLTB test cycle. This is really important for us because, especially with SCR systems, this gives us a really good picture of how they work in an urban environment. We've modelled this on a specific bus route, Route 159, Brixton on into Oxford Street. And when we are introducing new technologies, we report emissions annually as it is, and then we forecast what we're going to be in the future. And when we're introducing new technologies and getting funding, we really use this test cycle, the grams per kilometre we get from this cycle, multiplied by the kilometres that the vehicles drive, to predict where we go in the future and get funding for our SCR retrofits or DPFs or hybrids or electric buses, etc. So that's quite key to us, and all our emissions analysis is based on this cycle. We re-evaluated it quite recently. Probably the speeds have come down a little bit in London, and when we get to Euro 6 and we're really pushing high temperature NOx reduction, that is just slightly hotter. There's probably not quite enough idle periods in the test cycle. So in the future, we might be tweaking that slightly. And here we are so what I've done here is I've just taken a Euro 2 bus that we had tested on that Route 159. We got 12 grams per kilometre. I just indexed that, and in the blue, indexed, and then in red, that's the expected drops we should see with the introduction of the Euro standards. And things got worse at Euro 3. And I was a calibration engineer at that time for an engine manufacturer, so if a fair idea the kind of things, that was kind of like a very much a steady state focused test cycle, probably not realistic for the real world. In Euro 4 and 5, Euro 5 made no difference for us whatsoever, and probably at Euro 5 is sort of calibration tweaks at kind of motorway speeds, give them let them meet the tightest standard, but it was no benefit at all. Actually, some bus models got worse at that Euro 5. These are the average. But Euro 6 even better than we expected. So that's the sort of good news story. And the figures there, they've probably come down slightly. Our buses tend to be about 100 milligrams per kilometre now at Euro 6, and the worst ones are probably about 500 milligrams per kilometre. So a good news story. So these are emissions trends before we, up to 2013, before the SCR retrofit. We had really done a good job reducing PM because we retrofitted 6,500 buses with diesel particulate filters. But we had, because of like I showed earlier on, the huge growth in passenger kilometres and operator kilometres in the network, CO2 and NOx emissions were sort of going up. And then even with the vehicles getting cleaner, they were kind of plateaued. So our focus then was really going to switch to NOx reduction, CO2 reduction, and keeping that PM level low. So we decided, first of all, for our Euro 4s and 5s, almost exclusively had SCR systems on them, the engines that were in those vehicles. I think we had a few buses that just had EGR. We decided we would take the Euro 3 buses that were our worst in the fleet and retrofit those with SCR, that none of them had any selective catalytic reduction in there first. But we didn't just want to take the Euro standard, say, bring these buses to Euro 4. We wanted to push things a little bit further and fill in what we saw were gaps in the Euro standards. And one of the key things we wanted to do is limit NO2 emissions. So there's not capped in any of the Euro standards yet, but roadside nitrogen dioxide concentrations are where the limits are really an issue. So primary NO2 coming out of the vehicle is a big issue for us. And so I've tried to demonstrate that you can actually reduce total NOx and increase mass NO2 emissions by, you will look for that nice 50-50 NO to NO2 ratio for your quick reaction in the catalyst. But if you don't get a good efficient reduction, then you've end up increasing mass NO2 emissions. So that's something we really wanted to avoid. So this was a Euro 3 retrofit standard. So as I said, NO2 we'd put in there, and then we'd capped nitrous oxide at 5% of CO2 equivalent. So our catalyst manufacturers, and this is some data that's from Johnson Matthey, actually went away and looked specifically what they needed to do for an NO2 reduction and not just a total NOx reduction. And sorry, these plots mightn't have come out too good, but on the left there, you can see the NO2 to NOx ratio relationship of that to temperature. So you can really see why people push to get a good NOx reduction by the push for having a high NO2 proportion in the exhaust. And on the right, it's a plot of space velocity to temperature and showing the efficiency of the catalyst and the sizing of it and how important that is for overall NOx and NO2 reduction. So to develop special calibrations and size of SCR systems for our retrofit. And the first runs were really interesting because they are showing that they've actually increased NO2 from the standard catalyst and the standards, normal sizing, to the later systems they had developed where we were getting to 50% NO2 reduction we wanted. Shortly after, I think in and around the Volkswagen scandal break, and no one trusted anything we did in the test cell. So that went out the window. All the residents, and this is Putney High Street in London, and they were the most vocal residents. They, every year from, I think, I started in TFL, 2008 to 2012, every single year they exceeded their total amount of hourly limit value exceedances of 16 a year. They exceeded it within the first 8 days of the year. So by January the 9th, there'd be a huge press furore going on of terrible emissions in Putney. And I had got used to it each year. I could almost set up an automatic email to come out of my inbox just to prepare for the answers we were doing. It was so predictable. So this was one of the streets, and there's a lot of residents. At the same time, Oxford Street was very bad, but there was a lot of residents that lived here, so the residents were very vocal. So we took a bus and drove it up and down with a retrofitted SCR system and demonstrated with the NOx sensors on the vehicle that we were getting the same kind of 88 to 90% reduction on the road as we were in the test cell. So that was kind of good to see as well. Though interestingly on that, I think I said it before to some people here, the bus driver knew that someone from TFL's environment team was out visiting, and he started doing all this eco-driving where he never accelerated and was driving slower than a bus had ever driven. And I actually had to tell him, we need to get some accelerations in here because this is what gives us our NOx reduction and temperature and stuff. So you've got this strange thing where people think eco-driving is good, but actually what we need is a bus full of people being driven quite hard is very good for NOx. And this is what, with DFT match funded this scheme, they give us 5 million actually for the first batch of 1,000 retrofits. And they wanted to see how not only the NOx reduction that we demonstrated, but how that affected ambient nitrogen dioxide concentrations in Putney High Street. And on the left there, yeah, it's on the left. On the left, in yellow, you can see that there was a retrofit started to be introduced and rolled out on that street. And we had a very nice drop in NOx and NO2 concentrations initially. And it had started to go back up, and everyone was scratching their heads at this stage. And it was a bit of we weren't really sure what was happening, and we were thinking, I wonder, is there some construction or something going on in the area? But overall, that report found in that couple of months that there was a distinct decrease in ambient NO2 concentrations. And not just the decrease in NO2 concentration, but the amount of times the exceedances happened where you went over that hourly limit value came down 42% on the roadside and 71% on the facade, carbon facade. So that was good news story from that. Some of the remote sensing, yeah, okay, it has come out good. Sometimes this graph doesn't come out the best. Then this remote sensing that happens all over in lots of cities now, and this was King's College in London, they were doing this. They were doing a report to see the effectiveness of our retrofit scheme, and I've been telling everyone our SCR systems will get 88 to 90% NOx reduction. What they found was with our retrofitted buses, because we give them all the registrations of those, they sometimes, like a lot of times, they're given 90% reduction, but they found some of them, 60% of them were given 90% reduction, 40% of them were just acting like a Euro 3 bus. So they said on average, TFL's bus retrofit scheme is, or SCR systems are 45% efficient for NOx, which I wasn't happy with because I was wondering what is actually happening in these vehicles. Have they dropped out of their temperature threshold? Has someone forgot to put AdBlue in them? Is there a malfunction on the SCR system? Is it not maintained, etc.? So these are all kind of things we wanted to improve on for the next scheme. But actually, a couple of years later, and this is 2014, this came out, they finally published, but everyone had moved on from the project, but they finally published that that trend you see there, where there's been a big reductions in NO2 concentrations compared to the average, is where we've done a lot of bus retrofits. So years later, they said, oh, that was really good. But at the time, they were quite critical of it. So that was ultimately was a good news story, but we had some head scratching in the beginning as to why sometimes it looked like the systems weren't working. So nicely onto what we've lessons learned. So it was good. There was we had some question marks over it. So our Euro 5 to 6 retrofit, much more complicated now because we're taking off an SCR system that's already on there, putting on a new one with a later generation catalyst, much more efficient catalyst, but having to integrate that system with the OBD and everything else that's on the vehicle. So now it's a sort of electronic engine integration thing as well. So it's more complicated. We've got 5 suppliers on the frameworks, and a lot of them you'd be familiar with. This time we're doing between 4,000 and 5,000 vehicles. It depends on how the contracts renew, etc. We've got about 1,000 of them done so far. And I need to update this slide actually because we've actually, as I said, we now have to develop a solution for our new route master. The Scania and Mercedes have been test proven, but they haven't fully done their in-service durability test on the road yet. And this is the test standard now, because we're saying rather than we're not just retrofitting a bus, we're bringing it to a certain standard. So we've set the standards in and around what we think the Euro 6 bus should be, and we've also put those NO2 limits in there. And NO2 and N2O limits different than the Euro 6 standard. And really importantly, I had actually tried to get something similar to this in the Euro 3 program, but costs always come into play. And you know, at the time I was at Euro 3, you would have to put an extra NOx sensor on, and that was going to be very expensive. Now at Euro 5 to 6, everyone has got the separate extra NOx sensor. Now the expenses, SIM cards and telematics systems fitted to all the buses and broadcasting to us. The storage of data is a lot more expensive than I thought it would be. So our project managers and commercial people kept trying to cut funding out of this, but I was kind of going back to how I would sooner do less buses and have them and know that they work properly than have some out there and have question marks over what they're doing. So now every single vehicle that we retrofit is broadcasting to us. Each of those 5 suppliers will have a web portal, the registration of the vehicle on there. Is there AdBlue in the vehicle? Is the DPF bar pressure okay? Just keeping an eye on that for maintenance reasons. And we have a traffic light system. Is that system now working in service? So this is like, we see a really important step to getting a better understanding of how these systems are doing on the London condition. And also, if we do have that remote sensing, and I went out to see some remote sensing happening again, it didn't have any of our retrofit buses, but it had some new Euro 6 buses driving by. if there's any question marks, we can actually go back and GPS trace that data and look at exactly how we think that was doing NOx sensor-wise when it drove past that infrared remote sensing. And this is an example of some of the data we've got for one of our buses that are fitted. What we've found, getting the NOx reduction from these systems hasn't been the issue. It's the integration with the OBD. We found that's quite complicated. Our telematic systems, we've had some issues with those as well. We have a big issue with losing GPS data. So now we're getting our suppliers to use the vehicle's CAN speed. We still want the GPS data, but don't rely on that for calculating your distance, because we're dropping in and out of GPS signal a lot, especially where these telematic systems are fitted. They don't have a good GPS signal. Our NOx sensors, I'm actually not sure whether they interfere, or they're definitely cross-sensitive to ammonia. So we get different values from those than we do on, necessarily the sort of test, the actual legislative test. Our vehicles are definitely not doing that modeled Route 159 cycle all the way across the board. We have some routes where they're stationary for long periods of time and the SCR temperature will drop out, so we get higher grams per kilometre than the vehicle was certified. But we've also asked our manufacturers that are developing these systems, don't just look at the Millbrook test and approval, but also calibrate. If you're in a different dosing window on the road, look at that specifically and get it as good as you can without compromising too much the formation of deposits. And so here, this is now that was now we have the trends and forecasts in there. So we're forecasting the very big reductions in NOx, over 90% reduction in NOx from 2014 levels by 2020. So very, very substantial by getting every single bus we have up to the Euro 6 standard. It's interesting, effective scale, because in the previous trend chart, that red line looked like we had a huge drop in PM, and then it sort of plateaued, but it was gradually increasing. And that's because we had retrofitted our Euro 3s with DPFs, but the Euro 4s and 5s got to the low PM number without a DPF, but in actual fact, it had crept back up. So our newer Euro 4 and 5 buses were worse than our old Euro 3 buses. Thankfully now with Euro 6, they all come with DPFs, and we're retrofitting DPFs onto all the Euro 4 and 5 buses now, as well as the SCR. So we're going to get those drops back down to lower than we had when we had all Euro 3 buses retrofitted. So that's it, basically, in summary. The Euro 3 program was good, but there were some issues, and we wanted to tighten things up. Euro 6 really delivered. Euro 6 original equipment engines really delivered that huge benefit in service. So then we wanted to get everything to that standard. In London, we try and clean up our own, what we call a captive fleet, clean up your own fleet first, and then force the other vehicles to go ahead. So now we're rolling this out, and coaches, etc., coming into London will have to meet the standard. This is now turned into a national standard, so they can retrofit too. You can retrofit a Euro 5 coach, and it'll go on our systems as being Euro 6 compliant. And the telematic systems will give us a really good level of assurance that the vehicles are working, the SCR, and all the funding we've put in there is going to deliver the benefits in service. And that real-time data we have, lots of universities are very interested in this, and people can play around with this big data. I would be terrible at that amount of information. I wouldn't know where to start. But lots of universities and PhD projects now, there's going to be a lot of data there for people to use and really drill down into how SCR systems perform and in that kind of level in London. So that's it from me.